Hey there, folks. So, last episode, we went through and set up our defines for all of our Blackboard keys for use within our behavior tree. Between episodes, I went through and filled out a bit more of my comments that I was adding in there. And I also went through and fixed up some of the references that I had missed. But just quickly to go over what I did between episodes, you can see I've just gone through, added in, double hyphen there, added in just a comment referencing what each one is, what it does, things like that. So, like you can see here, we've got target character description for reaction value. I've gone through, described what it is. It's an int, what data type, and then provided what values. And then, as I mentioned, I went through the AI controller because I realized I had missed that. And I've gone through and added a bunch of these in. And the reason why for these comments, you may have just seen it, but adding this information in here, if you mouse over the usage, like here you can see it says what it does and the information there. So that's also very useful so that going forward, anyone working on this can quickly see what the information is for. And that's one of the other reasons why is it sort of gives another developer or yourself in some future point when you've completely forgotten about everything you've covered here or you've done, it gives you that information where you can quickly go, oh, okay, so that's what I need to do. Now, as I had mentioned last episode, this episode we are going to be working on the actual attack process for, well, the Wolf NPC that we set up last episode. So what we are going to do here, I'm just going to do a quick build. I haven't actually built since I've done any of this, but while doing that, I will try and walk through some of the stuff we're going to be doing. So we're going to need to set up another AI task for the behavior tree, and that's going to be the actual attack state, where we're going to want to do things like validate, are we still close enough? If so, we want to play an attack animation. When the attack animation goes off, we want to reset some values that are going to be stored within our AI controller because we don't want it to continuously attack. We want it to only attack like once, check, once, check, once, check. Because otherwise you're going to end up in this situation where your AI is looped in the attack animation but also following behind your target, or its target, I should say. Once we have all that set up where the AI is correctly attacking, we then need to actually set up the take damage process or damage application process. And what that's going to involve is adding a collider to our target, or sorry, our wolf in this case, and adding in some logic to the NPC. Well, actually, it's going to be the TF character class itself for taking damage. So with that, though, we're just launching into the editor now. This may take a moment just because it is a fresh build after I did a code commit to Git, as well as I made some changes. So what I'm going to do here, I'm going to pause the video, and I will be back as soon as I am in the editor. Alright, so we're back in the editor now. And just quickly before we start doing anything, I just want to go over the behavior tree and what we're going to be working on, because it's been a little bit since I've looked at this. So in here, in the behavior tree, we're not worried about our ranged yet, simply because we don't have any of the logic needed for ranged. It's something we're going to be dealing with later on in the series. So right now, we're going to be working on our melee, which is going to be specifically this attack. Right now, we just have a placeholder sequence node, so we do need to add a new task for that. And that's where we're going to be using some additional information that we're going to be adding to the AI controller to determine how we want to handle things there. So what we're going to want to do, close out of the behavior tree. We're going to want to go down to our C++ classes, project, public, AI tasks, right click, new C++ class as always, all classes, and then Blackboard base, Blackboard, not Bork, blackboard base, and BT task blackboard base. So covered this every other time we've done it, but this is the specific one we want for creating a blackboard task. There is behavior tree services, behavior tree task, my apologies, not blackboard. There's also services and decorators, but we're not worried about those right now. And we want BT task blackboard base. Click next. And then obviously following our normal convention, TF BT task melee attack. We're going to create that. It's going to open up in Visual Studio, obviously. And with that, this is actually the only thing we need to do in the editor for now. So as soon as Visual Studio prompts me for the reload, we're going to be doing that and just killing the editor because we haven't done anything in there yet. But to explain some of the basics, we're going to be going through here. Get rid of this one of the other headers. It hasn't reloaded yet, so we obviously need, as with all of our other ones, our execute task and our constructor, so we can get started on those while we wait for this. Go public our constructor, because we need to set a node name. Oh, do what I've done every other time. I'm just going to copy this over. And then our execute task. Save that. I'm actually surprised it hasn't asked me to reload yet. Yeah, the editor's still non-responsive, so it's still doing something. Now, while we wait on that, though, as I say, just to keep things moving along here, because I do want to try and keep these episodes on the shorter side, because there's going to be quite a few. All right, there we go. Reload. Reload all. Do you want to stop debugging? Yes. Come on, Visual Studio. All right, thank you. So as I mentioned, there's a couple of things we're going to want to do with this. The first one, though, we're going to wait for IntelliSense to kick in and let us actually create the definitions on these, if it ever decides to. Typical IntelliSense, it's taking forever. So while we're doing that, though, we can add some stuff to our AI controllers. So we're going to want a couple of booleans here. So we're going to bool should attack equals false, and bool has attacked. Oh, sorry, started attack equals false. Now this is actually, I'm trying to think, do I want to use that as a boolean, or could use an integer, because then that is going to allow us to actually, I'm going to change this to an integer. Integer attack process equals 0. So just to explain my thoughts here, again, just to give IntelliSense a moment here to catch up, I'm thinking this will have 3 states. It's going to be 0, do nothing, 1, can attack, and 2 is attacking. And the reason being for this is, as we set up in the animation with the notify, we want to, like I said, stop it from like looping the attack animation, like partway through restarting it and things like that. So we want to have something that we can control it. And as soon as we have 2 or more states, I'm thinking we might actually need a third, which is the reason why I'm doing this. This would be both of those booleans were false. This would be the first one was true, the second one was false. This was the second one was true, ignoring the first one. So, but we'll work on that as we go. So, are you going to let me? There we go. Okay, so we're going to quickly create these definitions. Okay, I'm going to save everything there. So this is just going to be node name equals melee attack Easy as that. Now, the execute task is where things get a little complicated. So I'm actually going to grab this here because the first thing we want is getting the controller. And obviously we're going to need our include for that, so I'm just going to grab that. Now, the other thing we're going to want, just like we don't have in, oh no, there it is. We want our pawn. So there is a couple of reasons to go through. First of all, we want the controller reference so that we can actually modify this integer we've just added in. We're going to add some functions to do that though, because we want to keep this as a private variable. Don't need that anymore. And then we're also going to want the NPC, because obviously we're going to want to determine if we're close enough to attack. So the very first thing we're going to want to do is determine if we're close enough to attack. So if NPC get actor location minus, now this is where we want to grab one of our other ones, move to character. Okay, which one's that? One before the end. Grab that information there. Get actor location is is greater than our get melee attack range. Okay, so this is where we need to include our defines, so we're going to grab that. And this is the part of the reason for that. Using the defines is we can very easily, what are you saying? Expression must have a, am I missing? Oh, I'm missing some other includes, duh. So the reason for the defines, come on, that gives you what you need. Let's fix that, yep. No, what are you saying? Must have expression must have class type, but it has type A actor. Okay, let's just pull this out. Oh, I know exactly why. It's a pointer and I've got a period in there. Treating it as a reference, not a pointer. Okay, so what we're doing here, sorry, now that my brain's working on that one. So we're getting the controlled NPC. Actually, I'm going to do this so we have visible get actor location. Oh, and need to go dot length is greater than. So just to explain, and this is something for anyone not overly familiar with C++ or programming in general, when you start getting a single line of code that is very long, like horizontally in the screen, as long as you have no control characters in there, you can break it into multiple lines. So we've got get our NPC location. We're minusing the get the actor location, dot length. And then we are checking to see if that is longer than the melee attack range. And the reason we can do this is the compiler doesn't care about white space. So as far as it's concerned, let me grab this there. that little highlighted section doesn't exist. That's the same as that highlighted section. Doesn't exist. So that's how you can get away with doing it. So, yes, we have NPC get actor location. So where is our controlled AI? Where is the target? How far away are they? If it's greater than our melee attack range, well, we can't attack. So this is going to be too far away. Need to move towards target. So what do we need to do there? Well, we need to do this here. Move to actor is this. That's fine. We need to set that move to state. Well, that is where's our defines? The attack type. So we need to set our attack type to move to target. So it's easy enough here. It's going to be owner comp.get blackboard component. Set value as int blackboard key underscore attack type. And what is our move to state? That is 1, I believe. Move to 0, 0. And then we want to return success. That's fine, we actually got that in there. Now, this is one I'm not sure I've explained properly in my other episodes. You want, if your AI task completes and you want it to say, I'm done successfully, reevaluate things, you want to return success. If you want to say, no, I failed, and that's where those like selectors versus sequence come in. If you're using a selector as its parent, you want to say return fail for it to move on to the right. If you want it to go, okay, this evaluated and we need to move on and reevaluate everything, you want to return success. And that's my understanding. I may be completely wrong on that one, and that's just because, again, I'm not the best when it comes to AI. I haven't done a huge amount of work of that within Unreal Engine. It's not like you see with your modern AI, like with ChatGPT and things like that. It's a different approach. So, well, now that we've determined that it's too far away, we've turned success, we need to continue on to the next one. So, and that is going to be, okay, we're close enough, we need to attack. So, this is where we want to access this. So, actually what I'm going to do here, so we can new property, visible anywhere, blueprint read only, meta equals allow private access. That is not a, that one is. Okay, so now, as I was mentioning, we want some functions here. So U function, blueprint callable, why don't I just copy this because we want it as a blueprint pure as well. So we want int get attack attack action state const. And what have I screwed up here? Did I screw up my allow private access? Apparently I did. Oh, yeah, I couldn't spell access right, that's why. I was missing the second S. Anyways, so get attack action state. we're going to just quickly create that. When this works, because apparently IntelliSense is being slow. And we're going to want to be adding 2 more functions for this. Actually, 3 more functions, because we want to call dedicated functions. We don't want to call a function that takes an input. So, return attack. What do we call that? Attack process? Yeah. Okay. Now, the next thing we're going to want to do, these are just blueprint callable. They're not pure because we're going to be doing some modification. So we want to add in void set starting attack, void has attacked, and void attack completed. Now, again, this may not be the best way to go about it. As I mentioned in a few episodes over the course of the series, right now what I'm doing is I'm getting the foundations of everything in place. They're not going to be the cleanest. They are not going to be the most efficient. The whole purpose of this is to get the foundations in place, to get what would be the fundamentals of the game in place. And once you have all of that in, you can start tweaking it, you can start balancing it, making it so that the code is more efficient. It has all the bells and whistles. You start putting your polish on there. But there's no point in spending forever polishing off your AI controller code in this case when, well, maybe we decide, or your team, you, however, decide that down the line you need to completely change the logic because it doesn't work with this other system. So you keep it as simple as you can, as basic as you can, simple, and like basically the KISS method, keep it stupid simple, until you're at a point where you need to start, I don't want to say overcomplicating it, but refactoring the code so it's more efficient and things like that. So set starting attack, we want that to be 2 is attacking, 1 can attack. Okay, so actually, yeah, so this is where I'm going to change this up. -1 equals do nothing. So that it's a typical negative state. So, so can attack, starting attack, and attack completed. And again, the reason for these comments is if we go back here, when IntelliSense wants to work, save that, I just did, you can see it tells us -1 do nothing, 0 can attack, 1 starting attack, and 2 attack completed. So I want this to be 0, 2, 1. Let's just add those semicolons in there. Now, I may have to change this because I'm already doubting myself on this one. But now that we've got that in, I've got another 5 minutes. So the next thing we want to do here in our task itself is int attack state equals con. And what did we call that? I've already forgotten it. Get attack action state. Get attack action state. So now that we've got that, now we could efficiently make this a switch and just call that in there. However, I want to do this switch on attack state. And this is what I was just saying, like, instead of being overly efficient where instead of doing this assignment, we're going to, like, instead of doing this assignment, we just put this in the switch case. I'm doing that because, well, this may not be the best way to go about it right now. It gives us some more flexibility. So if it's -1, case -1, case 0, and apparently my fingers are all over the board here, case 1, case 2, default. I'll throw a break in there. Okay, so if we're close enough and our current attack state is -1, we're just going to return succeed. Because obviously, actually no. Can attack, do nothing, can attack. 1 or 2, sorry. I'm trying to remember how I had planned this out because my notes don't really cover it properly. So attack completed means the animation has played. That's not attack completing. It's waiting for. Sorry, that's where my logic was flawed here. Okay, so if it is currently set to 2, we're not going to do anything. That means we're playing the attack animation. If it's set to 1, it means we're telling the animation blueprint we're going to start playing the attack animation. If it's 0, we want it to set to 1. Okay, so setting it to 1 is set start attack. And then we want to return succeed on that one. If it is 1, we are attacking, we don't want to do anything. So that's just going to be a return succeed. And then if it's 2, waiting for the attack to complete. So we're ready to play if possible. It is, we are going to, play the animation, wait for the animation to finish, and then revert back to this. Oh, okay, and that's what I missed, is the setting it to -1. Void clear attack state. Okay, so yeah, brain is not quite with it. So up here also as part of this, we want to go con clear attack. Thank you, IntelliSense, for not wanting to work. Okay, so yeah, up here we're saying we're too far away. We do not want to be doing anything attack related. So case -1, we should never hit. Oh, no. No, yeah, so if up here we've set it to -1, don't do anything. If it's -1 here, we need to advance it, and that is advance it to set starting attack. Just same as that one. So yeah, okay, so the way this works is basically in here, we would only hit the case of -1 the very first iteration of this, that we are now close enough to the target. which would put us in we need to start our attack sequence, which is set starting attack. So attack process goes to 1, which is play, okay, AnimTree, play the starting attack. We're going to have a function within the animation blueprint. We're going to call has attacked, which is what sets it to 2. And then attack completed once with the anim notify is going to set it back to 0 to repeat the process. So yes, okay. And then case 2 is, sorry, I'm just mentally working through these. Case 2 is waiting for the attack to complete. So we again just want it to finish. So what we can do here is just drop this down here because we don't want case 1 or 2 to do anything. The anim blueprint makes changes here. So I'm actually add a comment. Animation BP will control state here. No, let AnimBP know to take over. All right, and then obviously we just want a fail case if none of this is valid. So we'll just grab that from here and throw that in. So I do apologize. I know this episode is actually a little scattered. We haven't really done much in the way of visual work. However, this is another one of those where there's quite a bit of code work that we need to get finished off first before we can move into the animation and getting the rest of the stuff worked out. But I am going to end this episode here. We just crossed the 30-minute mark. Next episode, we're going to finish off making the changes to the... actually, no, not finish off. We're going to start all the work with the animation blueprint to get this state machine to work. And then more than likely the episode after that, because animation art is far from my strong suit. Episode after that, we're going to start work on the take damage logic. So, as always though, folks, thank you for watching. If you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below or hop over onto the Discord. Things are starting to pick up slowly on there, so if you feel like joining there, go right ahead. But as always, thank you, and I will see you in the next episode.